Press 100 buttons, see what happens.
Exactly. So I don't see the YouTube stream starting, which is a bit strange. Did I connect to the correct one?
I didn't have coffee yet. That's the problem. I should have had coffee. I didn't have coffee, and everything is slow. Oh, man. That's rough. That's rough. We
Cool,
made fun.
but we are now live on YouTube and Teams, and I'm just gonna do a quick sound check on the YouTube stream. So I'll mute myself for a second.
Sure. This is a sound check. We like to make sure things are working correctly. I can talk for a very long time live on YouTube about nothing until we actually talk about something, and that would be awesome. How does it
We
sound?
got it.
Good?
We are officially live, and it seems to actually work. My audio
All right.
is okay. So welcome to SQL Friday, everyone. This is SQL Friday number 138, and our returning guest is Ed Pollack, who will talk about why we should use calendar tables. I love the subtitle, the story of how little data can go a long way. So, Ed, welcome back. Nice to have you here.
Thanks for having me. I appreciate it. I love the schedule. I always say this. You're having lunch. I've been awake for 3 hours, so life is great. Good.
Awesome.
Ready to go?
Yes, I'm ready.
All right. Well, thank you for having me. This is a fun presentation today. It's one of those timeless things that, I can give this 5 years ago, 10 years ago, 10 years from now, and there'll still be relevance. There's really two purposes to this presentation. One is to talk about dates and date math and calendars. And the second part is how we can use a little bit of data or metadata to make our lives much, much easier. How centralizing really important things can simplify our code, allow for less errors, less mistakes, just make our lives better. So when I talk throughout this presentation about dates and calendars, substitute out other things too, like numbers or facts or account information or sales things. There's always like metadata that we use everywhere. That's very important. Maybe this could be a way to solve it. So let's dive right on in because this is fun. This is me. I'm Ed Pollack. I'm a Microsoft Data Platform MVP. I have done a whole lot in the data space and I love it. And right now, and I need to update this, blast, with SQL Saturday Albany, which was just announced. If you're anywhere near the northeastern US, come to SQL Saturday Albany on August 3rd. If you're not, virtually wave. And there we go. So let's
And
dive right on in.
if I'm not familiar with geography in the US, where is Albany?
Albany, New York is about 2.5 hours north of New York City.
All
So
right,
similar climate, but more space and less people.
cool. Thanks.
Thank you. Good clarification to have. Good clarification. So we're going to do a quick intro to calendar tables. What are they? And what can we do with them? Why are they useful? Why do we care? I have a lot of demo because live demo is exciting. When they break, everyone cheers. When they work, everyone cheers. So we're all good, right? And then we'll wrap up at the end with some questions if anybody has questions, or just wrap up. So what is a calendar table? Essentially, all it is a dimension table that contains dates and date components. I say it's a dimension table, but it does not work exclusively in data warehouses. It can be used in transactional databases, analytic data. It can be used anywhere. You can put it into your favorite analytic app. You can throw it into Fabric, Synapse. It really doesn't matter. You can put it anywhere you want. It can go anywhere. It's just a table, right? And tables can go anywhere. You can put anything in it related to a date. The most common format is you have a date and you have date components. And those date components can be anything. They can be date parts, like the day of the week, Sunday, Monday, Tuesday. It could be the day, which today would be what, 19. It could be position within week or month. Like, what day of the quarter is this? Is the third Tuesday of the year? Some of those are kind of hard calculations to do. You can even have different calendars, especially if you work in any fiscal or retail area. You may have different calendars you work with, or if you work with different cultures, you may deal with the lunar calendar, for example. And translating between different calendars isn't fun. I can't do it in my head very easily. I don't want to do it in my head, honestly. I'll make mistakes eventually. I'm human, so I don't really want to do that. And holidays. Holidays are different all over the world. We have some here, you have some there, and they're probably different. And even individually, we have different holidays. Keeping track of what days or what holidays is complicated. If I tell you to calculate when something is, it might be easy, might be hard. And special events, things that aren't actual holidays but are important to you or your organization or your business. We want to keep track of those, right? And not forget them. Like a birthday, for example, could be important, or simply company events. And another weird one is business days. Business days are important. When do we consider it a work day or not, or a school day or not, or things like that? Those are important to many people, but calculating it is a little harder than just saying, oh, I know today's business day. We have to ask, is it a weekday? Is it a holiday? Is it a special day? Do we have off for some reason? Did something happen? And maybe, I don't know. Was that the case on March 1st, 1999? I have no idea. I couldn't tell you. I have no idea. Not that I don't have the photographic thing going on. So whatever else you can dream up can go into a calendar table. And if you happen to have daylight saving stuff going on, you can put that kind of information in there too if you're crazy. But you can, and it could be useful to you. There's no downside to that. Where do we use these things? And the answer really, um, you'll most commonly see them in the analytics, places where you're crunching lots and lots of data, and you could join it into a calendar to know what happened on a weekday, or what happened on a holiday, or what happened on the 23rd of the month, or in this quarter, this week, this month. Very often found in analytics and reporting, making visualizations. If you need like a table of dates to left join into, so where there is no events, you don't get a nothing, you can do that too. If you're searching, they can be important too. You want to be able to search for something and understand, well, what happened at a certain date or a certain event or a certain sequence of time. You really need some way to do that, and it can be a big where clause, or it can be something like this. And if you have UI components that relate to date, like I can go and do stuff in the UI of your app related to months and days and years, complicated things, not simple things, complicated things. You can do all that in your app in code, or you could have it all stored in one place. So I'm going to quickly demo what we're using here, and then I'm going to use the same code for really this entire presentation. Where we do this isn't really that important. So a calendar table looks like this. It's a dim date, just like this. And you'll see there's a calendar date. I'm actually start running this now. I want it to run while I'm chatting, and then I'll talk about it. So let me just run this whole thing here. It may already have been run. I don't know if it's been run already. Let me actually just check and see. Has it been run? It's not been. Okay, great. So we're going to go ahead and run the whole thing, and then we are going to chat about it. And by the time we're done chatting about it, we'll have data to work with. So what is this table? I created a primary key on calendar data as a date. Depending on the systems you're in, the database you're using, you may have other formats or things you want to use for your primary key. But I use the date because it's natural and it is a primary key here. You have one date and a whole bunch of metadata. And you really can put anything in here. I have the string, month, day, year, quarter. I will share all this code later, by the way, in case you're looking for it. You don't have to go typing really fast right now. The name of the day, again, things that you may not think about, but you use a lot, right? The name of a day is important, and you can calculate it, but you may not want to. Then it gets complicated, like which Tuesday in the month is this? Or which Wednesday in the quarter is this? How many Thursdays have been this year? And again, these sound like real weird things, but people do ask for them. What day of the year is it? What day of the quarter is it? And it gets a little crazier here. Like, what's the first and last day of the week, month, quarter, year? Again, this is stuff that, if you need it, it's kind of annoying to get. But if it's already there for you, that's great. And I put some holiday stuff in here too. Some holiday, is it a holiday, and the name of the holiday. Again, this is arbitrary, but I put it in here because it may be valuable. And calculating these things on the fly is really annoying, honestly. Business days, weekdays, the previous business day. Again, these become things that we need to calculate a lot of these in code. It gets messy. Even just how many days in the month are there? That gets messy. It really does. And the population, I'm not going to walk through this proc too much. I didn't write anything super efficient or magical here. Please don't scold me about that. But again, you're only going to populate this sort of thing once. and maybe modify it once in a great while by adding some new elements to it. But this doesn't change much. So I just did it in a big old loop. You can do it however you want. It took a minute and a half to do like 120 years. So I'm not really concerned about speed. If you want it to be faster and more efficient, go for it. And I really just walk through and for every single day just calculate all the things I talked about. And the holidays have different rules. Some occur on certain days, or maybe the last Thursday of the month or something like that. So different rules. And I walk through all of that and assign them, and then we're done. And then here's how much we have, which is important. I go from 1980, you can go earlier if you want, it doesn't really matter, to 2099, the end of 2099. And that is 120 years of data, and yet it's only 43,830 rows. It's not that big. This is a small set of data. And the actual table is like 6 or 7 megs. It's tiny. Keep that in mind as we're working with this, that it's a very small amount of data. It's not big. This is minuscule. It really is. And we can look at our data here and see what it looks like. Here is this month, for example. Hey, here's today. Cool. And we can see information about it. Some obvious, like the month, day, year, the date parts. It's a Friday, things like that. But then also, what week of the quarter is it? What's the name of the month as a text I can use somewhere else? What's the first day of the week, last day of the week, and so on and so forth. It's not a holiday. No fun today, I guess. It's a business day. Boo. But anyway, there we go. Lots and lots of information. So we're going to dive a lot more into how we can use this soon. But I want to go back and talk a bit more about these. You're probably thinking this is cool, but why is it really useful? What can I do with this? Like doing things because they're cool won't impress anybody anymore, right? So what can we do? And I'm going to focus on the biggest reasons first, because there are a lot of reasons you can use this, but one of the biggest is simplify code. We very often get in the habit of doing things because we want to get them done, right? We write code, we release features, we want to finish things quickly and move on to the next thing and everyone's happy. And sometimes when we need to work with dates, we start putting in date math, things like this, right? And we put date diffs, adds, parts, pluses, minus, percents. We do all kinds of weird stuff with dates, and then we build on it over time, right? We change our requirements, we add daylight savings, we add time zones, we add more customers, and suddenly it's like, just give me the date part becomes like this date part and this date part and this date diff, and like you have a big long line of gobbledygook to figure something out, and it's hard to read, it's error prone, and it's hard to modify and maintain. And code that's not very maintainable may work, but eventually someone's going to make a mistake modifying it, working with it. And so reducing code complexity is very important. You don't want 10 lines of spaghetti SQL when you could have 1 line of easy to read SQL. That readability is important. You do want people to understand your code, and while maybe code shouldn't self-document, it should at least be somewhat easy to understand by looking at it. You should have an idea of what it's doing without me having to step over your shoulder and explain it in gory detail. Things like this seem funny. We laugh when we see code like this. Ha ha, look at all that stuff. But it's hard to understand what's going on here. And I can read through it line by line and be like, all right, we want day 3 of the week. Is that Tuesday or Wednesday? I forgot. Which locale am I in? Okay, I want month 3. Okay, March, first quarter maybe? I don't know. And then the day, what am I even doing there? I don't even know. So I did something here, and it's hard to read, and it's hard for you to read too, because I even wrote this code, and it's hard to read. So that's what we want to try to avoid is big, messy code. That's really the number one big reason why calendar tables are nice. And number 2 is going to be this, centralizing our business logic. So now we can get rid of our ugly code and make that go poof, which is important. All right, now we have the problem of we had messy code before, but that messy code probably didn't just live in one place. It probably lived in a lot of places, right? Odds are you have many different apps, services, layers, and things that have code in them. You have app code, web code, SQL code, store procedures, etc. You have analytic code. You have data out there in Azure or other places. And you may have similar logic in all those places, but you may not have it centralized. And what that means is that you now have all that date math here, 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 and here. What if that logic changes? What do we do? And the answer may very often end up being, okay, let's try to find all the places and change it and see what we can do. And that's a very hard thing to do. Finding the same thing in 20 places, remembering where it is, we can document it, but it's going to be hard. So we're taking all this date math and putting it into one table. And again, I use the word table, but it can be stored anywhere. Doesn't matter where. So we don't have to do the same thing over and over. Just apps, services, and your store procedures, functions, scripts, etc., 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 etc. Doing the same thing over and over and over. Error prone, we make mistakes, and you'll eventually give out bad data. And when you give out bad data, you might escape unscathed, or that bad data might go to somebody important who will not be so amused by the fact that you gave them bad data. Why does it say that the first quarter sales were this over here, but they're this over here? Why is that? Oh, oops, we forgot to copy some date math. Well, tell that to somebody important and see where it goes. What you really do is make a source of truth. And so things like holidays or special events can be in one place and well understood how they work. One nice thing about dates is they don't change, right? The past never changes. The day of the week on a certain day last year doesn't change. When was a certain holiday, like Christmas or New Year's or some other federal holiday or whatever? Those are easy ones. But when were they 10 years ago? Was it on a Tuesday or a Thursday? Those don't change. You can go back to 1800, 1200, 500, whatever. It doesn't matter. These things don't change. So even though recalculating all this stuff is expensive in code, we do it once here and we're done. And we don't have to touch it ever again, which is awesome. Special dates are out there. There's lots of them. And some are complex and some are easy. I kind of alluded to this earlier. Christmas is easy, right? It's always December 25th. You celebrate it, not celebrate it, care, don't care. It's always the same time of year, and it impacts a lot of people because people take off and see their family and do things. New Year's is always January 1st. We know that. Halloween is always October 31st in places to celebrate. The Thanksgiving here in the US is the last Thursday in November. Well, that's a little weird, but you can figure it out, right? I can figure it out on paper, pen, calendar, whatever. It's doable. You could do some math and code to figure it out. But it gets more complicated. Like, when's Lunar New Year? Can you tell me that one? Either you know it, or you're off checking a calendar, Googling it, something like that. It's not easy. It's complicated. And there are formulas for it. I thought about sharing that one, and that one was actually so silly that I didn't share it here. If you want to do it solely through formula, most Lunar New Years are calculated by taking a previous one and then doing the next one based on it. You can do that very easily. So it's complicated, though. How do you take different calendars and match them up? Lunar calendar and math. That's how you do it. If you don't have all that, you need more math. And Easter is
We
going
have
to,
a question for you, Ed.
oh,
If
sure.
is it okay to interrupt you?
Yes, please.
Uh, so the question is from Els. We have many different databases for different domains. Every database has one date table now, which is not the most centralized. So how do you have a solution for this?
It's a good question. And honestly, I'm not afraid of having the same table in multiple places as long as it gets maintained. I've worked in many places that have thousands, tens of thousands of databases all over, and they shared some common tables. And I'm okay with that. I prefer that to the alternative of not having it. If you wanted to, you could have a single date table in one database that's shared across all of them. I'm not sure if that's any better or not. I'm okay having that one table everywhere, just knowing that if we make a change to it, we've got to update it everywhere. It doesn't change very often, but at the same time, going through and saying in every database and every server, check for this table, and if it exists, modify it, or if it doesn't exist, create it. That code isn't terrible. It's certainly simpler than the date math I showed earlier, so I think I'm okay with that. And I do understand that like it's a little nerve-wracking to have a lot of databases, a lot of tables, and a lot of places. But yeah, one set of code is the key there, I think. One set of code that's reused over and over in many places makes your life easier. I hear typing. That's great. But thanks, good questions. I appreciate questions. I love questions. And you mentioned, yes, Easter is an example to be calculated as well. And I mentioned that one because I'm going to show it really quick. Only as a demo because I just want to show that these get crazy. And there are people that care about this. I've done this in the workplace before. Like people have asked, when will Easter be in the future? And yes, you can Google it and manually put it into a table, or you can put that code into your app. But how you calculate Easter is this. So this is called the Gaussian algorithm. And there are different algorithms out there for this. This is one of the earlier ones and one of the easiest ones to do. Yes, this is easy, via a simple page of code without more stuff going into it. And so what you really end up doing is you define your year, and you walk through a whole bunch of variables that define components of that year. And this is a real algorithm. I'm not making this up. This is, you can look it up. I put the Wikipedia link. You can look up elsewhere. It doesn't matter. It's pretty famous. It's in math textbooks, history textbooks. And you go through all this effort to figure out the Easter. Is it in April? Is it in May? So on and so forth. And then it works. And yeah, I can run this and find out Easter this year is on March 31st. That's a complicated calculation. And guess what? I don't want that in a where clause. Don't put this in a where clause, please. I don't want to see this code anywhere in an application because it's just such a mess. And no one's going to know how it works, honestly. Like, I knew how this worked when I first looked it up and wrote this. I have to probably walk through it for 5 minutes to understand how it works now because it's been a while. So, of course, you can make a function. And if we make a function to put all that code inside, I can then simply say, oh, I'll just grab the function and get the date and we're good. So we can calculate Easter. We can put in a function and try to encapsulate it, but it's still very complicated. And realistically, I never want to use this ever. It's just too complicated. And somebody jokes over there in the chat about leap years. Yeah, leap years are a whole different animal. They at least have kind of simple rules, right? It's every 4 years, except every 100 years, except in the every 200 years, except in the millennia, which is the exception to the exception. And then they have leap seconds to. You already said it. I love this. This is great. This is so fun. So anyway, calculating Easter is complicated. That's the theme here, and I don't want to do this more than I have to. I just don't. It's not fun, it's a lot of work, and it's error prone. Here's something else you may or may not run into, and it's worth talking about it because if you've dealt with this, it stinks. I've dealt with this. If you work for a company or an organization that has a fiscal calendar, a retail calendar, maybe they use a different cultural calendar they have to work with, like the lunar calendar, you may have to deal with those and know how things correlate across different calendars. And if you're not ready for that, it can be hard. For example, the fiscal year isn't always January 1st, December 31st. Many organizations are, but some aren't. Some start their fiscal year on September 1st or October 1st or something weirder than that. Why? They have reasons because of when they do business over the course of the year. It's not my decision, but you have to deal with that now. The fact that the first of the year is October 1st. Well, how does that sound? You've got to correlate our calendar to that calendar. If you work in retail, you may work by a 454 calendar or something similar. They have 455 and other ones. And what those calendars basically are they say instead of us having these months that have weird numbers of days, we're going to divide up each quarter into months that have 4, 5, and 4 weeks. And those subdivisions are even. That means each quarter is equal, and you can really report month by month, quarter by quarter in a meaningful fashion that isn't random with leap days and other weird stuff. There is a leap day in there, obviously, but it's more evenly spread out, and it makes a little more sense when you're working in retail. If you're not, this may not matter. If you work with the lunar calendar or some other calendar, that may matter. If you have a custom calendar, because you work in a field where things really matter. For example, if you're in an organization that sells most of the things around Christmas, you may have a whole special calendar based around all the holidays you sell everything on. If you sell flowers, you probably care a lot about Mother's Day. You may have special calendar considerations for that too. So calendars, important. If you need them, great. You can put them all in here. If you don't need them, awesome. You don't have to worry about it, but it's something you can have for free in here. People always ask, will this improve performance of my queries? And the answer is maybe. I put this here like 20 because it's not the main reason for using a calendar table. It can improve performance by reducing the complexity of your code. So as you get rid of all those crazy where clauses and functions wrapped around columns, you're faster. In terms of the performance of this table, though, it's really small. And if you're searching it and you're not searching by date, things can get slow because you'll join into a big table and then scan the whole thing because you're not going on an index. Just keep that in mind. It's a small table. Even with a big date range, even if you have hundreds of years, the example here was 120 years and 6.34 megabytes. That's nothing. That's like a millimeter, a tiny fraction of my cell phone storage. It's nothing. I page compressed it because why not? So it's tiny. Feel free to index it more. If you have a reason that you search on specific things in your calendar table, feel free to add more indexes. If you search by the day of the month, day of the year a lot, if you search by quarter a lot, just index the column. Don't worry about it. Or make covering indexes. Again, this is a small table, and you're not going to update it much. You shouldn't over-index it, But if you put a lot of indexes on it, I wouldn't shy away from it. I wouldn't poo-poo for having too many indexes in a table because you're not going to update it often. And if you do, it'll be probably in some release window. It won't be when people are using it most likely. So don't be afraid to index this thing. It'll improve the performance of your queries, and it won't really take up a lot of space because this thing isn't taking up a lot of space. The best performance gains you'll see in general will be when you take your where clauses and clean them up. If you where, if you group by, if you having, and those clauses have scary stuff in them, your performance will probably be scary. And by cleaning that up, your performance will be less scary. You'll simply not have to deal with the fact that SQL Server has got to evaluate a complicated expression before it can even go to the table and figure out what we're looking for. And this isn't just a problem of dates and complexity. There's another problem that we run into very often with dates, too, and that's the tally table problem. A list of numbers to join into, a list from 1 to 100, 1 to 1,000. I want to find gaps or islands or something like that. How do you generate that? If you don't have a table already there, it's kind of a nuisance. You have to kind of make things up as you go, make a CTE or something clever to give me a numbers set, and which one's more efficient, or we can just already have it. So in the world of a calendar table, we very often have a need to create a date range knowing things don't happen. Let's say, for example, I have a table of sales orders, and it's full of things that happen at specific date times, but some aren't there. And I want to know what days over the past year did not have sales orders. And I want to get that information back. Well, what do? I need a list of all the dates in the year, right? And are there analytics ways to do this in applications? Maybe. But if I wanted to get it done here and present it, how would I do it? And the answer would be I would take and select from my calendar table, and I'll demo this in a moment, and then just join whatever I want into it. Left join. And so if there's 0, I get a 0. If there's something, I get something, and life is good. So all the various trickery we use to try to make a numbers table, a dates table, whatever, that goes away. And the good news is we won't make any mistakes either because this data never changes. It's correct. You can check it all you want, QA it, and be 100% confident that it has what you want in it. And given that, you can use this to then put complicated filters against it. People ask funny questions sometimes, especially in sports, about winning streaks and losing streaks, things like that, scoring streaks. And sometimes they get weird. If you don't play every game, what's a streak like? Do you consider every daytime game, every nighttime game? How about in July? It's the warmest month of the year here. I don't know about there. That impacts play. How do streaks work? And you can calculate it much more easily when you have this left join ability. So let's go into some demos. I really want to demo a lot of what I talked about and show it because it's useful. And it'll help bring a little bit of context about for 25 minutes. So here's the query from earlier that I had an image of that we chuckled, right? And uh, there it is. It doesn't return any data, but it's a complicated query that's hard to read. And I don't really know what it's doing. I don't know if it's not returning data because it's wrong or because it's just there's no data there. I actually don't know. It's hard to read this thing. So let's simplify it. What that was really saying up there, um, it involved a month, a quarter, and a date, and it was complicated. Let's take an even messier one and try to fix it. So let's say that I was asked a question, a legitimate question. Give me all the orders from the fourth quarter of 2013 that occurred on a Thursday or Friday and not on Thanksgiving. It sounds outlandish, but in retail that means something. People shop at the end of the week a lot, and they tend not to shop on holidays. They might the day after, but those are special occasions. And so you may write a query like this, which will check for a year, a quarter, and then the 2 days of the week. And I've got to remember that 5 is Thursday and 6 is Friday. Depending where you live, that might be different. And then we're going to check and make sure that it's not um, these days of the week, and then it's not the end of the month. So it's not a Thursday or Friday at the end of the month, which would mean it's Thanksgiving in November. Yikes. That's complicated. I had to walk through that slowly and read it just now and make sense of it. If we use a calendar table, the dim date from earlier, and yes, it's underlining it for me because it hasn't been there long enough. You can chuckle a bit. But now this is easy to read. I still have a big where clause with a bunch of stuff in it, but I understand what's going on here. So I run this here, and I get back what I want. And I note that my code is actually correct now too, and it wasn't correct before. I had a mistake in there. I don't even know what the mistake is, but there was a mistake in there, and I fixed it by using a simpler query. This is a very intentional thing. I can read it and say, all right, calendar year 2013, calendar quarter 4. The day is Thursday or Friday, and the holiday is not Thanksgiving. It's really clear to anybody reading this, even if you didn't know how to code, even if you didn't know SQL, you could probably figure out what I'm trying to do here because it's so easy to read. And that is really, really awesome. How about date ranges? I mentioned that before. How do we generate a date range? And the answer is not hard. So here's a query here that gets me some data. I'm grabbing some counts, but I want to know all the counts for a date range, not just the ones where I have data. I want to know the zeros in there too. And I don't want to make up the rest. So I can see here I have 12 dates and they have orders, but what about the rest of the dates? This is for a certain salesperson. I want to know over the course of the year and chart it in a beautiful graph when they sell. I also want to be able to analyze the zeros and understand them. So how do I get the zeros? The answer would be to write a query correctly. Do I have an error here? No, I don't. Okay, phew. I have 365 rows for this particular year, and I can slowly scroll through and see I have lots of zeros and some orders. If I wanted to analyze those zeros, I now have them in a table, and I can see them, I can work with them. You may not need this in an analytics app. You may not always need this kind of information, but there are definitely times where you have a need for the zeros to use them in places. How many days last year were there zeros? How many were they less than 5 or 10 or 20? You can do that math very easily now. You can get an average that's meaningful, right? If I did the average of just this data or a median, I'm missing all the rest of the data points. And similarly, we can pull any part of the calendar table. You don't have to use the whole thing. You can always constrain it. I have 120 years of data. You may not need 120 years of data because your organization may not have existed in 1980, and 2099 may simply not matter to you yet. We can continue to filter, though, however we want. Like, let's say I want all the weekdays. I just do this and I'm done. It's great. I don't have to check for the day of the week number, which may vary across cultures. I simply say is weekday and I'm done. Great. How about correlating to holidays and weekdays and things like this? It's complicated. It sounds easy, but it's not. I can simply say, give me all the dates in 2014 that were not business days. I want to know what people are doing over on weekends and holidays. And there they are. And so I went ahead and I got all the orders in this table and joined them in. And now I know all the orders that happened on non-business days. Done. Just like that. Easy. And it's easy to read. I can also group data too, like this, and see like year over year, quarter by quarter, what does it look like? And again, you may ask, well, is grouping by this inefficient? And the answer is not really. If you're worried about performance, you could put a date boundary on things more, but this is fast and it should be fast. It's not going to be slower than it was before. I'm simply taking my data and I'm finding a better way to display it. So there we go. Calendar year, calendar quarter, order count, and I can see it's going up. Yay. So here's some outlandish stuff here. I have a database I created that has been it, and baseball's a sport played a lot here in some other countries, and I'm just going to look at information, fun information. Like if I wanted to know all the baseball games that were played on Easter in the United States, that's a question that could be kind of hard. It could be on any sport you want. It could be any sport that plays. You can do this. What occurred in a holiday? And oh, that's sad. Oh, we can fix that as we go then. I didn't create it in both databases. Well, we'll just copy this and we can all chuckle at me. All right. And the answer is none. There were none, which actually is a little surprising to me. I thought there were some. Hmm,
I
interesting.
think you used AdventureWorks 2017 database.
Did I? Oh, let me just make sure. Did I? Oh, okay. I thought it was in 2022. Well, I apologize. Thank you for that correction. Oh boy. Just give me a moment here to
And
keep typing for a minute, and then this is what happens when you do things live, everyone. It's fun. It's on YouTube. I don't have anything here, and that's honestly okay. I want to walk through the code anyway. I can troubleshoot my silliness later that occurred here. Something is wrong. I'll figure it out later. It's fine. Because the code is really important, and honestly, that's the most important piece here. If I want to get complicated, and say I want everything that happened in a certain year in a weekday, I can do that. And it looks nice and clean. I can do complicated things. Like I want to know things that occurred at Wednesdays at night, but not on holidays. And you may say, who wants to know this? But if you ever watch any sport, ever, they come up with facts and information that are absurd, that are totally absurd. Like, how does this person do in July at night? And it sounds silly, but it's meaningful. And, my game data has some filters, but my date data does too. Not a holiday and Wednesday. Easy to read. I can join in further and get sums of stats and so on. And yeah, betting companies. I see the comment about online betting companies using this information. They're very interested in everything down to like the temperature. Who plays well when it's hotter or warmer out, certain times of day. And guess what? People do. I know that I have more energy now than I will at like 8 p.m. tonight. I know that. I'm a morning person. And so if I were playing a sport, you'd want me in the morning. You want me in the day games. You would never want me at a night game. And I would do worse. And that would matter to people. And so on and so forth. And so all the filters that I have in my dim date table here are clean. They're easy. Is it a holiday? Is it a Wednesday? I can group by it. I can really do anything I want here. And it's nice and clean and simple. And that's really the benefit of this. Whether it improves performance or not, it does so many other useful things for us that it's really worth having because I can read this. And that is really, really meaningful for me. I want to wrap up and take questions in chat because this is a fun topic and I could show demos all day about how clean the code is, but we get the idea on how clean the code is. And it's worth talking a bit about it before I jump to questions, just on kind of the wrap up and purpose of all this. And so, so much waiting in baseball. Yes, that is very true. Many sports, honestly, are that way. There's downtime. I totally understand and sympathize with you in a modern world where we move fast. Slow is hard. Probably the best reasons to have a calendar table or something like it is to simplify our code, make it clean. I showed lots of demos where the code went from this to this, and it was easy to read. That's huge. Very important, makes your lives easier. Centralizing important business logic, whether it is in a single database, many databases. That was a great example before about what do I do if I have a lot of databases. And the answer is you centralize the code that generates it. Very, very important. You again don't want to have the same thing being done differently in different places. You want the same thing done the same way everywhere, no matter if it's in different applications, different databases, different services. It doesn't matter. Analytics, transactional, it doesn't make a difference. You want to do the same thing everywhere, and this allows you to do that. You will probably improve your code performance, almost guaranteed, because you will unwrap all of your date columns from all the crazy date parts and date diffs and date adds, and you'll simplify that code. You still have to be concerned with indexing, and you may want to throw a lot of indexes in your calendar table, and that's fine if you do, because it's small, and you can do that, and it's not written very often. But test still your performance. You'll find that in general, things will get simpler and perform better when you don't have mountains of code all wrapped around it. And it can help us answer hard questions easily. This is something really useful and important. We ask a lot of harder and harder and harder questions in our world. And I've been asked questions before. Real world example. So I was asked questions in the past. I'll give a couple examples. One was related to retail, where how do sales change during sporting events or major concert events? Can we target advertisements, for example, towards specific events or locales based on that? And the answer is very often going to be yes. For example, is there a major concert for a major star like Taylor Swift or somebody going on out there in a certain place? That's going to have a local impact, right? What if you advertise locally to that area, something you're selling that their fans may want to buy? Well, we need to know when she performs and get that on a calendar and centralize it and put it somewhere. And I also had to answer the question of how do people shop before other holidays? We know people shop before Christmas, but that does evolve over time with like Prime Days and everybody having their Black Friday sales and stuff. But I want to analyze, understand how do people shop for things before, after, and during holidays, and not just Christmas and Thanksgiving, but what about Mother's Day or Father's Day, or even President, weird holidays you would never think about that are on the calendar, some bank holiday. Do people shop differently? And the answer is I've got to first find all those in the calendar and understand them. And then I do remember a single question that was asked to me once that became this big, like, we want to post all over social media. When the World Cup was going on a few times, I remember a CEO who was a big World Cup fan. And that was great. That was fun. We had all kinds of cheering and rooting, and everybody kind of like got into it extra, and that was fun. And they asked, we want to know live and for like, the next few days, how people's behavior changed in our application when the World Cup was going on, leading up to it, during it, and then. And that wasn't just a joke question. They meant it. They wanted to go on social media and talk about it. And that was a big deal to them. So I couldn't just say that's a silly question, haha. Like they meant it. And I was able to answer it really fast because I was able to very quickly just put the World Cup onto the calendar and then put all the past ones on, put all the future ones on. I got that data out of a database, joined it all together, updated the calendar table with some new columns, and then there it was forever to have it. And then whenever anybody asked that question in the future, you would have that data waiting for you. So these are fun, interesting examples. There's more. There's many, many more. I did work with retail calendars before, and working with them and not having an easy way to join between them is painful at best. So yeah, I've used this a lot in real environments in production and analytics and data that goes to CEOs, and it makes your life a lot easier. It makes you more confident on what you're doing, which is awesome. I see a question about here, complicated data models. Woo! I see a lot here. So you could have multiple dates, dates in motion, dates things were voted on. So could you join the same date table multiple times? Yes, you could join that date table as many times as you want. Again, it's small, so you're not going to pay a huge performance cost. Just make sure you're writing some good SQL or whatever analytics engine you're doing is making efficient joins. But yeah, you can do that. Alternatively, a calendar table can be more than a calendar table. I've seen people do this before. This gets interesting, and you may or may not have use for it. But I've seen people take the calendar table and break it up into an hours table. So I have not just date, but I have date and hour. Or I have my date table here, and I have a separate table over here that can join into it with individual hours throughout the day. Like, is it daylight? Is it nighttime? Are there special events going on? Do certain processes happen at certain times of the day? And you can do that. There's no reason you can't. The data still won't be that big. 48,000 rows isn't that big. Multiply it by 24. It's not monstrous, really. But you can do that. So I'll continue reading what you're saying here about Power BI and your visualization. So how do you get your Power BI devs to stop using dates from the table itself because the joining gets complicated? And that is a good question. So one possibility is to have multiple different tables, if that makes sense, but I wouldn't want the same logic in multiple tables. I think that in Power BI, you simply want to have each instance of the table instantiated as a different named thing, which sounds weird, but each one should have a different purpose, and you should be able to maybe name it for that purpose. Again, these are all just ways to solve a problem. There are other ways too, ones I'm not thinking of, ones you're not thinking of. We can talk about it more later. If you continue to have this problem later, we can chat about it too. I thought about that actually. Do you want to have a calendar table as a memory optimized object? And I had that conversation with myself yesterday while I was reading through this. And I said no. And the reason I said no is that it's not fitting the use case for memory optimized very well. Memory optimized tables are awesome for highly transactional, contentious, locking, blocking, write heavy tables where I could put that in memory and all of that contention goes away. For a table that's simply being read, I'm not going to save much because it's got to be in the buffer pool anyway. It's got to be in memory anyway, whether it's in the memory optimized table or here, it's going to be memory and pretty fast. The difference though is that the memory optimized object can't be compressed. Here's a little known secret. You can't compress memory optimized object. And so it'll actually be bigger in memory than it will be in the buffer pool. So you can test this for fun if you'd like. I doubt you'll see a performance benefit for this, only because it's memory versus memory, compressed memory versus uncompressed memory. And so you probably wouldn't see a performance gain. But it's small enough you can test and play with if you want. But that was kind of the conclusion I drew. But great question. And I thought about that and drew that conclusion. And it seems the correct one.
And I
And
think also the joins between a memory optimized table and a row store table or a disk table, it it's pretty elegantly solved in the SQL Server code, but it's a bit wonky what's going on behind the scenes because it's not pages versus pages, it's something else versus something else. So
Yep. If for there was some reason you were writing this table often, which would be a little unusual, there could be a benefit to put in memory maybe, or if it was very contentious, if people were all smashing it constantly, and you didn't have a good isolation level, maybe. There's probably other solutions to that problem though. And to that point, though, I've said maybe you should have multiple calendar tables for different calendars or different purposes. And I say that very easily because these are inexpensive. One of the benefits of calendar tables is they're small, they take up very little space, and inexpensive. At first glance, you may think 150, 200 years of data is a lot, but it's not. In a world where tables can have billions or trillions of rows, this is like a grain of sand. And so it consumes very, very little space. And so don't be afraid to play with this. Don't be afraid to make the table really wide. This is a table that could have 100 columns, and I don't feel bad about it. This could be a table that has 20 indexes on it, and I wouldn't come down and say you over-index the table because, again, this is very much a read-only-ish structure. You'll update it occasionally,
mm.
but you won't update it often. And therefore, it's read-only mostly, and so it doesn't really matter if it has a lot of indexes on it. And it was 6 megs. So what's it going to go to? Like 20, 30? Uh-oh. Expand the disk drives. We're in trouble. Like it's not going to happen. So
Oh, I've lived long enough to see where 20 more megabytes is a problem, but we don't have that anymore.
I do agree, though. Space isn't cheap, though. I will say, people often say that disk space is cheap, storage is cheap. It's cheap until you need a lot of it and you want it to be fast,
Yeah.
and then it begins to get expensive, and you begin caring. And will 5 megabytes ever break the bank? No, not today. You're right. There was a point in time where 8 megs of RAM was a big deal, and we're not there anymore. But even today, though, you benefit here by at least this presentation being on something tiny. And
Mm.
you can extend this elsewhere too. The calendar table idea isn't just for calendar tables. The idea can be extended to anything you want. A number table, a tally table, really anything that you have that you do very, very often in code that is messy can be put into a dimension table and reused in many places. And the benefit of that now is you centralize it, you don't repeat it over and over, and you can get all the benefits you saw in this presentation for something else. And there are lots of others there. And so you may have other reasons to make a dimension table and normalize this into something that can be reused. And one of the cool things about it is I can project into the past and future. And you may have that
Mm.
benefit elsewhere too. I can go back to 1980, 1920, 1900. I can go out to 2100. And not everyone cares about that right now, but some organizations do. NASA does. If I want to send a probe out of the solar system, uh, that may take a while. If the European Space Agency wants to study Mars for 20 years, I can't do what I do in production, say I'm going to partition a table up through 2028, call it a day. You may have to go further than that. So just think about the future and the past and how that affects us and how easy it is to go really far. I put my info here because I love questions. If anybody has any questions right now, it's a great point you made on cloud storage there, and I have this conversation all the time. The cloud is cheap until you get bigger, then it gets more and more expensive and more expensive. And then you're playing tricks and games to make things cheaper in the cloud storage. And I fully agree on that one. There there are definitely scenarios in today's world where companies that are in the cloud are leaving the cloud because it's too expensive. It won't apply to everybody, but it depends on your data profile, your app profile, and what you're storing there. It can get crazy. I
No,
do want to say,
I think you
oh,
have
go
to
ahead.
think about it before before you start migrating everything to the cloud, think about how you do it. Think about, should we rewrite some of this stuff? Should we make this thing that fits on a Windows server fit into a SaaS service? Would that make sense? And actually put some thought into it and not just have it as usually it's a business decision that we should be in the cloud. And I mean, by itself, it doesn't mean anything. It's someone else's data center, and they will charge you for it. So figure out how to do it, I guess.
And within your application too, how well is it architected? If you use a database inefficiently, then it may be inefficient in the cloud to additional degrees. Like if you store all your files and documents and images and binary stuff in a database, and your database is a petabyte, relational database because you have a lot of files in there, it's going to be very expensive in the cloud. If you put the files into
Mm.
some storage location that's appropriate for files, it'll be cheap. And people make these decisions all the time. And when you're small, you don't notice them. When you're big, they matter. I do want to mention really quick, I have my info here. Feel free to connect with me. I'm happy to chat about this or other topics later. I've written and spoken on this topic before, so there's more information out there if you want more demos and things to look at. But feel free to contact me and we can chat later if you have questions. In the meantime, are there any questions? Does cost analysis be tested on UAT after migration from a dev environment? That's an interesting question. I'm
Mm.
not sure how it's relevant. Um, if we're talking about cloud versus on-prem or something like that, or a release, I would certainly say the cost analysis is probably something you want to do long before you get to that point. At least I would. And I do that all the time. Part of our jobs as data professionals is to understand what do things cost and what will they cost and how do we make them cost less? Because usually cost less also means perform better. Not always, but they do go hand in hand. If you reduce the size of something from this to this and it costs less, it'll probably perform better too.
Mm.
Before I run off into like way over there somewhere, does anybody have any other or comments or anything on calendar tables in this presentation? We having a great conversation. Just want to make sure we don't have anything to ask about the presentation before we have fun.
I've got one. It's not a question, it's more of a comment because you said it's tiny, even if you put in the hours and even if you do this and that. I've had calendar tables where I have all the time zones in the world as a part of it because things are different for reporting, or we have the culture because Easter is different depending on if you're this or that, and so on. And then it becomes a lot of rows, but even so, if you always query the dim date table with the culture, we'll just put that as a first key of the clustered index and you'll be good because even if the table is huge, if I'm in this specific application only read a certain part of it, well then that part isn't big. I could even partition the table by culture or something like that. So it's don't be afraid of it being big. Just make sure you don't scan the whole thing every time you use it.
Yep. It's really your imagination is a limit here. And I really don't see two calendar tables anywhere that are the same. They're different everywhere because everyone has different needs for it.
Mm.
Everyone has different things they care about, different holidays, different cultures, time zones, daylight, so you name it. There's a million things we can talk about that go in there, and you'll care about some and not care about others. So you can really customize it.
Yeah.
Is it a good practice to have time data be used as an index in a calendar table? If it's relevant to you, if you're searching by it a lot, honestly, yeah. I mean, again, this is a small table. If you're searching by something a lot, like I did most of my searches on date, but I did do some on like quarter, month, day, create indexes on them, experiment. But if you're not writing the table very often and it's compressed, it's not going to take up a lot of space. I bet the 6 meg table I could put 30 indexes on it, and maybe it would hit 50 megs. Maybe. I'm not even sure if it would. That's not that much. It's really small. So I wouldn't be afraid to index it.
I think if you pre-allocate the table for like 200 years ahead, probably the system won't live that long. And it becomes big enough to for it to make sense, then I would at least try to just compare with a clustered column store versus a row store and see what the difference is.
Yep.
At least on older versions of SQL Server, you're more likely to get your queries running in batch mode if the calendar table is a clustered column store. So then for reporting purposes, that probably makes sense.
That's a fun
If
point,
it
and I'm going to demo that too, I think. I'm going to demo that through because in a clustered column store, you'll simply have one row group. It's probably all you're ever going to
mm,
have, and you'll just read that one row group every time in whatever segments you need. That's kind of cool. I hadn't thought of that.
Yeah, and if it's I mean, if it's ordered ahead of time, so let's say you create the cluster, the normal clustered index, and then change it to a clustered column store, then probably the row groups will be pretty perfect for, or I mean, the segments will be pretty perfect for your purpose of elimination. So,
That is 100% correct. And it's such a good idea, and I wish I had thought of it, that I'm going to go ahead and do it and post about it soon because that was a great idea. And so I will also post at some point soon. I'll probably put it on LinkedIn and maybe write something about it in Column Store World, which I spent a lot of time in, about how this could just be better in Column Store. Because why not? Why not? I think
Mm.
you won't get any elimination from having it be in the correct order because you have one row group, but the segment elimination will be nice though. Having 50 columns or 100 columns and only reading the segments for the columns you need would probably provide enough of a speed benefit that it won't matter. You'll read all the rows, but you're only going to read one column out of 100. That's a pretty good deal.
Yeah. Yeah,
Great
and
idea.
when I look at the compression rate of a cluster column store, it's like it's hard to understand how it's done until, and even if someone explains the bits and pieces inside of it, it's still hard to understand that it can be that compressed because there's nothing left of the space. So,
I have written on the compression and really dove into the white papers and how it's stored. I actually know exactly how column store is stored, and even then, it still feels like certain things just feel a little bit like magic to you sometimes. It could just be like
yeah,
our age and where we've been, what we've done in the past. Maybe just, when we were young, computers were so clunky and slow and everything. But there are just so many things that feel like magic still, and that still does. Like taking a 1 terabyte table and turning it into like, what, like a 50 gig table or something like that. That's magic to me still. It's magic I can explain, which makes it science, but it feels special. It really does.
I really thought first time I looked when Column Store was new back in SQL Server 2012, they were read only, etc. But they made sense for a data warehousing purpose. You'd make a Column Store out of a partition in a fact table or something. I thought they had forgotten to implement column store functionality into SB space use because it was so tiny. So I'm like, it must be wrong. And then just looking at the data file itself, I shrunk it, and well, that's all that was left. There's nothing in it. So amazing.
Yeah, it's good stuff. I do love it when technology impresses you. And it was unfortunately it was one of those features when it first came out, it wasn't as impressive, but it got much better with
Hmm.
time. And like today, once you get like 2019, a lot of the clunkiness in the background is gone and it's so smooth.
Yeah, and I think someone might have thought, well, why would I put a dimension table into an OLTP database? But I haven't seen an OLTP database for the past 5, 10 years that is not also a reporting database at one time or another, because you do reporting on OLTP data. You don't wait for it to land in a data lake or data warehouse. You report on the transactional data itself. So
And every
it
app I've
only
ever
makes
used pretty much at this point has had in it a dashboard or widgets or some way to like visualize your stuff, right? And the moment you're
sense.
doing that, crazy queries hitting analytics, right? That's what it
Yeah.
is. Against transactional data, which is always going to perform like fun.
Ed, thank you for coming. I don't see more questions in the chat. I just got a call from my sister. I think she wants me to help out with the birthday preparations. So
Ah, well, that sounds like fun. Have a great time. Birthdays are fun. I love birthdays.
I will. So I will stop the stream.